Hello everyone. So in this last section of Module 7, we will discuss multiplying and dividing signed numbers. So let me give you the rules for multiplying two signed numbers, and then the rules for dividing two signed numbers are very similar. So to multiply two signed numbers, first of all, what you do is you sort of ignore the signs by taking the absolute value. So you multiply the absolute values of the numbers first. So multiply the absolute values of the numbers. Okay, then to figure out the sign of the answer, right, of the product, if the signs are the same, if the signs of the two factors are the same, the product is positive. So if the signs of the two numbers are the same, then the product, which is the answer to the multiplication, is positive. If the signs of the numbers are different, so to say, if the signs are different, then the product is negative. Okay, and I can illustrate that by just doing a little diagram here, right? If I have, let's say I have a positive number, right, times a positive number, or if I have a negative times a negative, right? If the signs are the same, then the answer is going to be positive. So I'll write same sign, then the answer will be positive. If I have different signs, so if I multiply a positive times a negative, or a negative times a positive, so if I have different signs, the answer is going to be negative. Okay, now division is basically the same rules. So I'll just say the rules for division are similar. So the rules for division are similar to those of multiplication. Okay, and instead of writing out the rules in words again, let me just use this shorthand notation here. So if I divide two numbers, so you can either write it as a ratio, right? That means division. Or I could write it like this with the division symbol. So if the numbers have the same sign, so if I divide two positive or if I divide two negative, again, or I could write it like negative divided by negative. What is the result going to be of the quotient? It's going to be positive. So it's the same rule, right? Same sign, my answer is going to be positive. So if I have the same sign, then the answer is positive. And then if I have different signs, so if I divide a positive divided by a negative, which I could also write like this, then my answer is going to be negative. Or if I do a negative divided by a positive, right? So I have different signs. The answer is going to be negative still, right? So if I have different signs, the answer is negative. So really it's the same rules as for multiplication. Okay, so let's do some examples here. Let's say I have let's say I want to multiply -3 times 7. Okay, so the rule is you just find the absolute values, but that's a quick way of saying that is just ignore the sign, right? So find the absolute values, multiply the two absolute values together. Well, 3 times 7 is 21. And then since I have a negative times a positive, the answer has to be negative. So it's -21. If I multiply -4 times -200, ignore the signs, right? Find their absolute values. So that's going to be +4. Absolute value -200 is +200. Multiply the absolute values. That's going to be 800, right? And then I have a negative times a negative, same sign, so the answer is going to be positive. So this is just a positive 800. Okay, and then after doing a few of these, you probably won't actually write out the absolute values. For addition and subtraction, sometimes it's useful to do that. But multiplication and division, you tend, after doing it a few times, not to do it anymore, right? So again, we ignore the signs. I'm just going to multiply 1.8 times 0.7. So this would be 56, right? 5, 7 plus 5 is what? 12. And then I need to move it 2 places. So that would be right here. And I have a negative times a negative, so this is going to be a positive 1.26. Okay, and again, these numbers can be any real number. So let's do a problem with fractions. Let's say I have -5/6 times 2/3. So ignore the signs, right? Just multiply 5/6 times 2/3. We know how to do that, right? Typically we simplify first. It looks like I can do a little bit here, right? 2 goes into 2 once, 2 goes into 6 3 times. So I have 5 times 1 is 5, 3 times 3 is 9, but then I have a negative times a positive, so when I want the sign of the correct sign for the answer is going to be -5/9. Let's say we have -1/5 times 2.5. So again, take the absolute values, which means ignore the signs, and just multiply 1/5 times 2.5 first. Well, remember, to do this, we have to convert that mixed number into an improper fraction. So that will be what, 5/2? Now I can multiply, but I can simplify first. 5 goes into 5 once, 5 once. So this is going to be 1/2, 1/2. But then when I go back to the original problem, I have a negative times a positive, right? So the signs are different. So the answer is going to be negative. So this should be -1/2. What about this? What if I have -6 times -4 plus 2.7? Okay, here, we have order of operations, right? Remember, the -6 in front of the parentheses, that means multiplication. So I have multiplication there, but I have to first do what's inside the parentheses. So I want to solve this first, right? I want to do -4 plus positive 2.7. So I'm adding two numbers. They have different signs. So the rule is I find the absolute value of each number, So this is going to be 4. Absolute value 2.7 is 2.7. I subtract largest minus smallest. So I need to borrow here. This is going to be what, 1.3? And then I keep the sign associated with the larger absolute value, which is 4, and that's going to be negative, right? So this really, I guess, is negative 1.3. So now my problem becomes negative 6 times negative 1.3. So I can multiply, again, find the absolute value. So you have 6, 1.3. Another way of saying that is ignore the signs. Now I'm going to multiply 1.3 times 6. So 6 times 3 is 18. Carry the 1. 6 times 1 is 6 plus 1 is 7. And I have 1. I need to move it in one decimal place. But it's a negative times a negative, so this is going to be positive, right? 7.8. Same sign. When I multiply, I'm going to get a positive answer. So it looks like the result of this whole thing is just going to be positive 7.8. That would be the answer. Okay, so same thing with division, right? If I have negative 12 divided by positive 4. Just think of it as 12 divided by 4, which we know is 3, right? But it's a negative divided by positive, so since there's different signs, the answer must be negative 3. So that will just be negative 3. And by the way, I could also write the problem like this, right? This also means division, so that would be negative 3. Negative 20 divided by negative 2. So take the absolute values. Again, after a while, you don't really write that out, but that's going to be positive 20. This will be positive 2. Divide their absolute values. So 20 divided by 2 is 10. And then since we have a negative divided by negative, same sign, the answer is going to be positive. So this is positive 10. Okay, what about negative 2/3 divided by 4/5? Okay, so ignore the signs, right? We know our answer is going to be negative because we have a negative divided by positive, so we know it's going to be negative. So actually, here, I'll put that in now, negative. Ignore the signs. We're just working with the absolute values. So I'll do that on the side. I have 2/3 divided by 4/5. Well, remember how to divide two fractions, right? The first fraction stays the same, and I multiply by the reciprocal of the second one, right? The dividend stays the same, and I have to flip the divisor. It becomes a multiplication problem. Now, to multiply these, I can simplify a little bit first, right? 2 goes into 2 once, 2 goes into 4 2 times. So 1 times 5 is 5 for my numerator, and then 3 times 2 is 6 for my denominator. So my answer is going to be negative 5, 6. Why negative? Because I have a negative divided by a positive, so different signs, this is going to be negative. How about this? Negative 30 divided by 1 1/2. So first of all, immediately convert that mixed number into an improper fraction, right? So this would be negative 30 divided by 3/2. And you can think of negative 30 as negative 30 over 1. Now, I know my answer is going to be negative, right? So this is going to be negative. I ignore the signs because I'm just working with absolute values now, and I'm going to do this division. So I have 30 divided by 1 divided by 3/2. Well, that's the same as 30 over 1 times the reciprocal, right? 2/3. I can simplify a little bit. 3 goes into 3 once. 3 goes into 30 10 times. So I have 10 times 2 is 20. 1 times 1 is 1. So this is just going to be 20. But since it's negative by positive, it's going to be negative 20. So that's going to be the answer. So negative 20. What about this? What if I have negative 49 divided by negative 7 squared minus 4 times the negative 3. Okay, so here is where order of operations are really important, right? So I need to do exponents first. Parentheses, but there's not much I can do inside, right? The parentheses, they're just numbers inside, so I can't really do much. So I need to do the exponents first. So I need to do negative 7 squared, and you have to be careful here. The square, right, the exponent, is acting on the entire negative 7. This means negative 7 times negative 7. So that's going to be positive 49, right? 7 times 7 is 49, but negative times negative is positive. So it's positive 49. So I'm going to rewrite this again. So I have negative 49 divided by positive 49 minus 4 times negative 3. Okay, now what comes next? Well, the division is going to be next, right? It beats out subtraction. Oh, sorry. I have division and I have multiplication. I have to do these left to right, right? So that's why it comes next. So I have division, multiplication, subtraction. Division, multiplication beat out subtraction, but since division and multiplication are at the same level, they have to be done left to right. So I'm going to do this first. Negative 49 divided by 49. I'll write it this way. Well, negative divided by positive is negative, and what's 49 divided by 49? That's just 1, right? So this is going to be negative 1. Now I can do my multiplication, so I have 4 times negative 3. Well, that's going to be a negative 12. Right, so this becomes negative 1 minus a negative 12. And now I can rewrite that subtraction into an addition problem. So the negative 1 stays the same, subtraction becomes addition, and how do I do this? I add the opposite of negative 12, which is positive 12. And then what's negative 1 plus positive 12? You can work this out. You're probably pretty good at this now. This is just 11, right? So that's my answer. This whole thing simplifies to 11. Okay, let's look at this word problem here. It says a man lost 1.8 pounds per week through a diet and exercise program. And the first question is, what was his net change in weight after 15 weeks? And the second question is, if the man weighed 183 pounds at the start of the program, how much did he weigh after 15 weeks? Okay, so first of all, the man is losing 1.8 pounds per week. So there's a sign associated with this value, right? In fact, we can say since he's losing 1.8 pounds, I can call that a negative. So it's a negative 1.8 pounds per week. That's like our rate. Times, and this was done for 15 weeks, right? Times 15 weeks. So if I multiply those together, that should tell me how many pounds that he lost after 15 weeks, right? That will be his net change in weight after 15 weeks. Notice here that the units of weeks cancels, right? And I'm going to end up with pounds, which is what I want. So I need to multiply this together. Well, a negative times positive is going to be negative. And then I just need to multiply 15 times 1.8. So this would be 40, right? 8 times 1 is 8, plus 4 is 12, 0, 5, 1. So it looks like this is going to be 27. So negative 27, and it has units of pounds. That's the net change in weight after 15 weeks. Okay. So that's basically we've answered the question, part A. How do I answer part B? If the man weighed 183 pounds at the start of the program, how much did he weigh after 15 weeks? Well, that's going to be his weight at the beginning plus his change in weight, which is negative 27, right? Usually we'd say subtract 27, but really we're adding his net change, which is negative, which happens to be negative. So, well, we know how to add two values together, right, with different signs. I find the absolute value of each number. So this is just 183. Absolute value negative 27 is positive 27. I subtract largest absolute value minus smallest. I'm going to need to borrow here, right? So this is what, 6, 5, 1. And then I take the sign associated with the larger absolute value, which is positive. So it looks like it's going to be positive 156. And it makes sense, right? It has to be positive. So his weight after 15 weeks is going to be 156 pounds. Again, I mean, the quick way you can think of it, it's just 183 minus 27. But really, since we said that the net change is negative 27, we're adding the net change to his original weight. Okay, and then let's do a couple of problems from your My Open Math homework. Okay, in this problem, I just want to calculate this product. Well, since everything's being multiplied together, it doesn't really matter what order we multiply things in, but we'll just do it left to right, just so you remember to do, if you have multiplication and division, it definitely has to be done left to right. So it's a good practice just to do that. So I want to do negative 5 times positive 4 first. Well, I know my sign's going to be negative, right? Because negative times positive is negative, and 5 times 4 is 20. So then this becomes negative 20 times negative 4. Right? That's what I have remaining. Well, negative times negative is positive, and 20 times 4 is 80. So it looks like this is going to be positive 80 would be my result. Okay, what about this one? So use the order of operation rules to simplify the expression as much as possible. So we have addition, we have multiplication, right? Remember, this means 7 times whatever the result is in the parentheses, right? Since it's next to it, it's multiplication. And parentheses, so I really need to do what's inside the parentheses first, right? So I need to do the negative 6 plus 9 first. Now, we can use our rules, or these numbers are small enough you can just do this in your head, right? Think of this as if you owe $6 and you get paid $9, what's your net result? You're going to get paid, you're still going to have $3, right? It's positive 3. So now this becomes negative 3 plus 7 times positive 3. Now what do I do next? Well, I have to do multiplication, right? Well, positive 7 times positive 3 is going to be positive 21. And then now the only operation left is addition. So I have negative 3 plus 21. So again, think of it as money. If you owe $3, but you get paid $21, what is your net result? Your net result is that you have $18, right? Positive $18. So this must just be equal to 18. Okay, what about this? So here, again, we have to be careful with these, right? If I have an exponent, the exponent only acts on the thing right next to it. So in this case, if I have negative 3 to the third power, the exponent 3 only acts on the 3. The negative is that's going to come into play later. You're going to add that at the end. So I need to do 3 to the third power first. Well, that means 3 times 3 times 3, right? So this is what? This is going to be 9 times 3, which is 27. But then I still have that negative out front, so I have to write the negative there, so it's going to be negative 27. Okay, the next question, negative 2 squared. But now the whole negative 2 is in parentheses. So that exponent 2 acts on the entire negative 2. So this is like saying negative 2 times negative 2. Well, we know a negative times negative is positive, and 2 times 2 is 4. So this is just equal to 4, right? Remember, you ignore the signs, right? You take the absolute value of each number. So that's 2, 2. 2 times 2 is 4. And then we have a negative times negative, same sign, so it's going to be positive. So it's just positive 4. So in this case, this is positive 4. What if we had this? What if we had negative 2 squared? That would be different, right? Because then the exponent here just acts on a 2. This we have to hold off, wait until later. 2 squared is just 4, and then I put that negative back in front. That would be negative 4. So you have to be really careful about the exponents and whether you're exponentiating the entire thing in parentheses or just the number. Remember, it always only acts on the thing right next to it. Since this whole thing is in parentheses, it acts on the entire thing in the parentheses. Okay, let's see if we can solve all of these questions here. I'll start with the upper left. So I have positive 5/6 times positive 2/3. So I know my result is going to be positive, right? I can simplify a little bit. So 2 goes into 2 once, 2 goes into 6 3 times. So 5 times 1 is 5, 3 times 3 is 9. So this is going to be positive 5/9. Okay, I'll do the one right below it. So I have a negative 5/6 times 2/3. So we know, since we have a negative times a positive, we know our answer is going to be negative. Then we can ignore the negatives, right? We can just work with absolute values. So really now I'm just working with 5/6 times 2/3. Again, I can simplify it a little bit, right? This is 1, this is 3. So 5 times 1 is 5, 3 times 3 is 9. So this is going to be negative 5/9. Okay, over here I have a negative 5/6 times negative 2/3. So it's negative times negative, so it's going to be positive. And then again, if I multiply 5/6 times 2/3, that's going to be 5/9. Right, so this is going to be positive 5/9. And then the last one is 5/6 times negative 2/3. So again, positive times negative is going to be negative. I only need to work with the absolute values. They're giving us the same values here, right? So this is again going to be 5/9. So it's going to be negative 5/9. Okay. So really, in every case, right, the absolute value of 5/6 or negative 5/6 was 5/6. The absolute value of positive 2/3 or negative 2/3 was 2/3. So I multiplied them together to get 5/9. And then I got the sign here by looking at the sign of the two factors, right? Positive times positive is positive. Negative times positive is negative. Negative times negative is positive, right? Same sign, positive. Opposite signs, negative. And then positive times negative is negative. Opposite signs. Okay, and then let's just do a similar problem with division. So see how all of these numbers are basically the same. The only thing that's different is the sign, right? Whether it's positive or negative. So if I just do 17/12 divided by 5/6, let me do that out. Well, first of all, we know how to divide, right? The first fraction stays the same, and I multiply by the reciprocal of the second fraction of the divisor. Right? That's how you divide fractions. I can simplify this a little bit. 6 goes into 6 once, 6 goes into 12 2 times. So this is going to be 17/10, or 1 and 7/10 if you want to write it as a mixed number. So I'll just leave it as an improper fraction, right? 17/10. So now the only thing that's going to change here is the sign, right? So if you look at this first one, I have a positive divided by positive. So my answer has to be positive, right? So this will be positive 17/10. Here I have a negative divided by positive. So that's going to be negative, right? Different signs, I get negative 17/10. Here I have a negative divided by negative, so same sign, the answer is going to be positive. It's still 17/10, right? Because it's the same values. And then here I have a positive divided by negative, so different signs. The answer is going to be negative, so this will be negative 17/10. And that would be it. Great, so that's it for Module 7 on signed numbers. And then next we'll look at Module 8, which will talk about just some basic statistics, basically mean, median, and mode. Great, thanks.